Okay. So we are doing the capital allocation line construction. We have already seen the objective of the capital allocation line and the equation, the derivation, where we see that the expected return for the combined portfolio is your basic minimum risk-free rate plus the Sharpe's ratio of the risky into the standard deviation for the combined portfolio. So for creating a combined portfolio, first we will start with only the risky assets. Reason being, I want to create an optimal portfolio first, because I told you on the CAL, capital allocation line, all portfolios have to be optimal. Whereas on the efficient frontier, not all portfolios will be optimal. So if I start with risky assets, I have taken ITC and HDFC Bank. There's no specific reason for it. Both of them are traded on the exchange. Both of them will have standard deviations, and therefore both of them can be considered as risky assets for the risky portfolio, right? So the first step always is to, what is the first step? To convert the prices to returns, because returns is a more scalable measure. So I will first find out the monthly returns. I have taken data for 1 year from November 20 to December 21. You can always update it with the most latest data. So I take the returns, which is next minus previous by previous. And I create these returns for all the months. Same way for HDFC Bank, I do next minus previous by previous. And I create the monthly returns for both ITC and HDFC Bank. Now to create a risky portfolio, I will need a base case. So I will take the portfolio as ITC and HDFC. The weights, you can start with random weights. So I will take 0.25 and 1 minus 0.25. Sum of the weight should always be equal to 1. Is that right? What is the returns for this portfolio? Returns annualize अगर हम मुझे करना है तो what will be the annualized returns for ITC? I can take the average monthly returns here. Take the average. This is your average monthly returns, right? So multiply it by 12 to get your annualized returns. Is that correct? Same way for HDFC, we take the average monthly returns for HDFC and multiply it by 12 to get the standard deviation of HDFC also. Returns of HDFC. What about the standard deviation or the risks? Now, please remember, when you have to annualize the risk, it's not as similar as return. When you have to annualize the return, you can simply multiply the mean monthly return by 12. That's what we did for ITC and HDFC. But to annualize the risk, we can't multiply by 12. Why? Because variance, which is a grosser measure of risk, is proportionate to time period. Standard deviation, which is the root of variance, will be proportionate to the root of time period. So to convert the monthly risk into annual risk, we cannot multiply by 12. We have to multiply with root of 12. So your risk will be standard deviation of your returns for ITC multiplied by root of 12, which is 22.08% for ITC. Variance, which is the grosser measure of risk, is proportionate to time period. Standard deviation, which is the root of variance, will be proportionate to the root of time period. So we don't multiply with time period in case of risk, we multiply with root of time period. So that's what I did. I multiplied with root of 12. Same way for HDFC. We take the entire standard deviation and multiply it with root of 12. Later, I've already said it twice. So this is the reason why we take root of 12 and we multiply it and we get the return and risk for both ITC and HDFC. Now we are in a position to find out the correlation between ITC and HDFC and use that correlation to determine the portfolio return and risk for the risky portfolio. Isn't it? For the risky portfolio, this is your. So I'm going to take this as my risky. Correl, how do you get your correlation? Correlation is Correl function. Take the correlation between the ITC returns and the HDFC returns. So your correlation turns out to be 0.213 between ITC and HDFC. ठीक है ना? Now we can find out the expected return for the portfolio. So the portfolio return for the risky portfolio, I mean, will be what? The sum product of your weights and your returns, which comes to be 17.29%. A simpler way to understand it is weight of ITC into return of ITC plus weight of HDFC into return of HDFC. Portfolio risk for the risky portfolio will be square root of WA square into sigma A square plus WB square into sigma B square plus twice weight of A, weight of B, sigma A, sigma B into R, which is 17.05% for the portfolio. This is risky portfolio. Now we will also, what do we do for optimization? If you remember, we have to find out the Sharpe's ratio and maximize it. So this is, I will call this as my base case. And remember, I told you we never ever touch the base case, right? So currently, what is my Sharpe's ratio? If I assume that the risk-free rate is 6%, what is my Sharpe's ratio? RP, return of the portfolio, minus risk-free rate divided by standard deviation of the portfolio, which comes to currently 0.663. Currently, it is 0.663. Everybody agreed? So now I am going to create an optimal portfolio here. Where I'm going to copy these risks and returns. I'm going to copy the correlation. राइट? ये कैसे चेंज हो गया? हाँ, ओके. This will change because I have no, I haven't frozen the cell. RP minus RF. RF has to be frozen. Divided by sigma P. ठीक है ना? So now I will optimize the portfolio. For optimizing the portfolio, I can simply go to the data tab and solver, and we set the objective as Sharpe's ratio, set it to maximum by changing the weights, right? And add a constraint that the sum of the weights is equal to 1. Press OK and solve. So now you see that the Sharpe's ratio is maximized to 1.052. It is much higher than the base case Sharpe's ratio. The base case Sharpe's ratio was 0.663 and the maximized Sharpe's ratio is 1.052. And it tells you that put 85% of your money in ITC, 15% of your money in HDFC, and you will have the maximum Sharpe's ratio. ठीक है ना? So we can also create a data table here where I put the weight of my risky, the weight of risk-free, and the Sharpe's ratio. है ना? So weight of risky I take from here, risk-free, no, sorry, not yet. My mistake. This should be weight of ITC, weight of HDFC, and Sharpe's ratio. So weight of ITC I take from here. Weight of HDFC is 1 minus weight of ITC, and Sharpe's ratio is currently 0.663. And then what I will do is I will create a graph or table here starting from 0, 0.1 and going up to 1. And just to check कि मेरा Sharpe's ratio actually उस जगह पे optimal हो रहा है या नहीं हो रहा है, what should I do? I should insert a row between 0.8 and 0.9 and copy this weight here, this one. Just to make sure कि वहां पे actually मेरा Sharpe's ratio maximum हो रहा है या नहीं. And now I can create the data table. So data, what if analysis data table, I go and link it to my only independent input in the base case, which is the weight of ITC. And I press OK, and I will get all my Sharpe's ratios. And now we have to compare ये कहाँ पे maximum है. You will see that it is actually maximum here. Same thing, 1.052, 1.052, 85% in ITC and 15% in HDFC. And that's where your Sharpe's ratio is maximum. है ना? So what does this tell you? It tells you कि अगर मेरा ये efficient frontier है, for risky assets, I told you, right, that for efficient frontier it only considers risky assets. इसमें कितने सारे risk और return के combinations हैं. If you take the risk and return and Sharpe's ratio, there are so many combinations. But सिर्फ एक ही combination पे वो maximize होता है. So if I have to plot an efficient frontier, I will insert two more columns. And what should that be? What should I insert? Portfolio, I'll call it as P return, portfolio return and P risk, portfolio risk. So यहाँ पे, this is my portfolio return, this is my portfolio risk, and now my sharpest ratio. And now if I take the entire block and create a data table, link it to my only independent output, ये देखो, ये आ गया आपका return and risk, and this one I'll just convert it into percentage. So you get मैक्सिमम शार्पेज रेशियो. अब अगर ये सारे रिस्क और रिटर्न के कॉम्बिनेशंस को अगर मैं प्लॉट करता हूं तो आई शुड गेट माय एफिशिएंट फ्रंटियर. तो आई जस्ट टेक ऑल दीज कॉम्बिनेशंस and plot it here in by way of a chart here. बट पहले मुझे रिस्क करना पड़ेगा, फिर बाद में on the x-axis it should be the risk, which will be from here, and on the y-axis I should take the return, which should be from here. है ना? And now let's see if I make it. Yeah. See, now you get the efficient frontier, don't you? आया ना? This is the same efficient frontier which you can see I have drawn on the board also. The oval-shaped frontier. Parabola line, rather. So that's your efficient frontier. तो हमें क्या पता चलता है कि इसमें कितने सारे, if you look at the graph here, कितने सारे रिस्क और रिटर्न के कॉम्बिनेशंस हैं. There are so many risk and return combinations. But is the portfolio optimal in all the combinations? No, only one combination where I put 85% of my money in ITC and 15% of my money in HDFC Bank. Then I get an optimal portfolio because that's the point where my sharpest ratio is maximized. So अब मैं क्या करूंगा? Remember when we started with the definition of capital allocation line, what did we start with? We started by saying that capital allocation line, unlike the efficient frontier, is not just a combination of risky assets. It's a mix of risky and risk-free assets. So I will create a cal portfolio here now. So this is my cal portfolio where I will have the risky assets also and risk-free assets also. Now the weights can be random. I'll just take any random weights. So maybe I take 60% or 25% in risky and or 60% in risky rather. Take anything, it doesn't matter. 60% in risky and 40% in risk-free. Sum of the weight should always be equal to 1. But now you have to be very careful. When we are constructing the capital allocation line, I told you the base or the crux is that all portfolios on the CAL, which is the capital allocation line, are optimal portfolios. Which means when we combine the risky assets with risk-free assets, हमें risky का combination वो लेना पड़ेगा जहां पे our Sharpe's ratio is maximized and the portfolio is optimal. And when we do that, we will get these return and risks because यहीं पे आपका at this point your Sharpe's ratio is maximum. So I've just combined it in a manner that my risky will always lead to the maximization of Sharpe's ratio. Risk free, what is the return for risk free? We have already discussed 6%. लेकिन उसमें कोई रिस्क नहीं है, isn't it? And we don't need, do we need the correlation when you combine the risky assets and risk free assets? Do you need the correlation? You don't, because the second term and the third term become zero. You saw that in the derivation. So what do we need? The portfolio return, the CAL portfolio return would be equal to what will it be equal to CAL portfolio return? Correct. Sum product of my weights and my returns. And what is my CAL portfolio risk? Do I have to do the whole formula again? Not required. What is sigma C? Now देखो, weight of the risky into standard deviation of the portfolio. So यही करना है मुझे यहाँ पे. Weight of risky into standard deviation of risky. Isn't it? Weight of risky into standard deviation of the risky portfolio. Because हम क्या करते हैं? We would have done WA squared sigma A squared. बाकी तो zero है. Same ही आता. So my portfolio risk is what we used in the derivation, in this case 11.82%. Now what we can do is we can create another table here and I can say weight of risky, weight of risk-free, CAL portfolio return, CAL portfolio risk, and Sharpe's ratio. Or rather, we don't need the Sharpe's ratio. बाद में देखेंगे. So now let's see. If I take my weight of risky from here, weight of risk-free will be 1 minus weight of risky. CAL portfolio return is 18.44 in the base case. CAL portfolio risk from here. And now I take starting from 0 to 1. In fact, we can go up to 2. And we take the, this is your base case again. And let's try and plot the data table and we see what happens. तो ये आ गया आपका कैल पोर्टफोलियो का रिस्क और रिटर्न. ठीक है, एवरीबडी ओके? I'll tell you. I'll tell you the reason. Very good question. I will tell you the reason why I did it. Now what we will do is I will plot the return and risk. I will add this data here on the graph which we had prepared. Select data. I'll call this as efficient frontier, my current series, and add another series, call it as capital allocation line. Here X values again we will take as the risk. Y values we are going to take as the return and press OK. ये देखो. Can you see the same line coming up? And यहाँ पे अगर आप देखोगे, you will see the tangency also. If you broaden the graph and widen it, so it is tangent at one point, and that point is called as the optimal portfolio. Same graph you got, which I drew on the board there. This point where it is tangent is your optimal portfolio, and that is your capital allocation line. Now, what if you look at the equation of the capital allocation line? What is the slope? Sharpe's ratio of the risky portfolio. So if I take the slope here, slope of the capital allocation line, it will be what is equal to slope function. Take the known y's and known x's. So known y's are your returns, known x's is your risk. What do you get? Oh, I took the wrong line. I'm so sorry. So sorry. यहाँ आना चाहिए. Either. What is the slope of the capital allocation line? You take slope y. This is your return. Known x's, take it from the risk. See? Slope of the capital allocation line is the Sharpe's ratio of the risky portfolio, which was 1.052. Same. What is the intercept of the capital allocation line? What should it be? Risk-free rate, isn't it? So intercept of the capital allocation line, known y's, return, known x's, risk. What do you get? 6%, which is your risk-free rate. So we saw that the slope of the capital allocation line is the Sharpe's ratio of the risky portfolio, and the intercept is your risk-free rate. So we have covered all the intended topics for capital allocation line. What is the capital allocation line? It is a mix of risky and risk-free assets in the optimal combination. What is the slope of the cal? Sharpe's ratio of risky. What is the intercept of the cal? Risk-free rate. What is the equation of the cal? Expected return of the combined portfolio is risk-free rate plus Sharpe's ratio of the risky into the standard deviation of the combined portfolio. Is it clear? And we have not only studied this graph as a concept and the derivation, but we have also constructed it on the Excel. Make sense, everyone? Thank you very much.